right? A body moves in a straight line such that its displacement in S meters at time t is given by the formula S is equal to 90 minus t cubed. Find S when t is 1. Simply put t is 1 into this formula to give us S. That's the relationship. S is some function of t. So you just put t in there, you'd get 9 minus 1, which is 8. And then find the values of t when S is 0. So you make now S 0. So 0 is equal to 9t minus t cubed, which is going to give us, you can factorize t, you get 9 minus t squared. Yeah, right? And they're both equal to 0. So t is equal to 0, and 9 minus t squared is equal to 0, which gives us t is equal to plus or minus 3. Okay, that question just basically asking you how familiar are you with the fact that S is some function of t. That's all it is. Okay, now let's look at this second question. Change in displacement between these two t's. Simply put these both into this formula and find the difference between them. So if I did, because remember S is some function of t, if we know what t is, we can find out what S is. So if we know what t is for at time t, we know we can calculate what S would be, which would be S is equal to 5t squared minus 2 cubed, which is going to give us 20 minus 8, which is equal to 12. And then we do the same thing, but with t cubed, so 5. So with t being 4, so 5t minus, let's use the calculator now. 16 times 5, 18, I think. Then minus 4 cubed. 16 is the answer. So what's the difference between 16 and 20? It's 4. So the answer here would be 4. Okay, and then it says change in displacement in the third second. And it gives a little hint. The third second is the time between t2 and t3. So what is the change? So we'll just calculate what t3 would be. So put t3 in here and do the same thing. So when we put 3 in there, we get 5. 3 squared minus 3 cubed, 18. So what's the difference between 18 and 12? Because that's this is t1. This is t4. And this one here would be t3. We'll calculate t3, which is 18. 18, what's the difference between t3 and t2? It's going to be 6. And that's how you solve that. Okay, so that's the first two questions. Find the velocity when t is 1, you put it back into the formula because that's how you find out what v would be. And then the greatest speed. How would we work out the greatest speed of the particle between 0 and 4? One of the easiest ways to do that is by just giving it a little sketch. Give it a little sketch. Right? And that's my sketch, right? And then I'm gonna what I will do is work out the if there's any. I would use a formula to find out the roots of the equation. So it's going to be minus 1, 5, 3. It's going to give me 5.5. So let's say 5.5. And something here. Minus 0. Also minus a half. It's not exact numbers, but it's close enough. It's a sketch. Then I'm going to draw the sketch, and I know it's going to go at it's upside down. This is good. Something like that. Okay, so what's the greatest speed? So this is v, and this is our t. between 0 and 4, 4 somewhere here. The greatest speed would be the greatest difference between the x-axis, or yeah, the x-axis, and the greatest displacement between, sorry, no, the greatest speed would be the point within the range, so within 0 and 4, that is furthest away from the x-axis. I can see it's going to be somewhere here, the middle point, wherever, because a quadratic has a line of symmetry. So we need to work out what that minimum point, minimum point is. So how do I do that? I get the two values that I calculated from being the roots, which is going to be the actual roots were x is equal to plus or minus 5 plus or minus root 37 all over 2. Cool. So if I add and minus, if I add them both together, what am I going to end up with? I'm going to end up with 2 root 37 over 2, which is basically root 37. I'm going to double check that on my calculator. So we've got 5 plus root 337 all over 2 plus 5 minus root 37 over 2, which just gives us 5. Actually, my bad. This gives us 5. We'll fix that. 5, right? And then I'm going to divide that by 2 to give me 2.5. Okay, 2.5 is the middle. Okay, and then from there, what do? We go about and we plug that back into the formula to find out the V, what that V would be. So we would say V is equal to 3 plus 5, 2.5 minus 2.5 squared. What would that be? 3 plus 5, 2.5 minus 2.5 squared is equal to 9.25. Good. Okay. Question 4. Same thing, find the maximum displacement. To find out the maximum displacement, the first thing we need to do is we'll stretch the curve. So we've got, if let's say 4t minus t squared, I don't really care about this function. It's not going to really affect my sketch, because when I equate it to 0, that's going to go anyway, for the roots anyway. So it's going to be t, 4 minus t is equal to 0. T is equal to 0. T is equal to 4. So I'm just going to go like this, go like this. Okay, what was that? Yeah. So I'm gonna sketch a curve. It's a negative curve, so it's gonna be something like this. I think, does it have any range? No, it doesn't. So let's go like that. Cool. Everything's falling apart. Hey. Okay, maximum displacement. So we're just looking, actually, sorry, apologies. It says at time t is equal to 0, a car is at point P. Cool, it's at point P. It moves, so straight away we don't need to, we can ignore this stuff. It moves in a straight line from point P and then returns to P. Okay, so its distance from P, its distance from P, s meters at time t seconds, can be modeled as that. So we're just looking at it between the time it comes back. We're just looking at this part here. So the maximum displacement would be somewhere at 2. Okay. And then the time taken for the toy card to return back to with the toy card to return to P, what would that be? For the toy card to return. So okay, so let's carry on. Let's put this back into here. So we're gonna get a fifth 4 times 2 minus 2 squared. That's gonna be a fifth 8 minus 4, which is 4 over 5. Okay. B, the time taken for the car to return